Sorry. I'm very sorry. Can I have another water, please? Hello? Can I have water, please? Water? Water? Yes.
Outside.
Outside?
Yeah.
What? I'm sorry. Yeah. Can you try the other pocket? It's fine, it's fine. It's fine. Is this file right? The file is correct. This is the file. We need another file. Yeah, we need two files. There's this one and there's another one. Oh, it doesn't then? Okay. So I think it's better if you copy this to the desktop rather than reading them from the memory. Slides? Okay. Next. Is it previews? It's preview? Okay. Yes. Can we have sound for the computer? Not now, but later minutes.
This code is okay. This or this? This one. This one.
This is actually a maybe on the first, the other ones. think something is from over there. If it doesn't work, it's fine. You're losing time. I'm sorry for the delay. Okay, sound doesn't work that well, so it should be fine. So, welcome everyone to Unite India 2019. This talk is about making retro games with Unity. Its name is different in the agenda, so if you are here for making a complete game with Unity, I try to cover both here and then some. But we have more slides than we have time for, and that's by design. So I'll be sharing the slides online, and we'll be giving it to Unity people as well, because I wanted to be working as an standalone notes for later on. Maybe you could pass it to your friend and it would work. You don't. If I did my work the way I wanted to, you wouldn't need to be here. So you're wasting your time, obviously. But first, let's talk about who is this guy. My name is Aydin. I'm an indie game developer for about 10 years now. I've been doing lecturing and consultation on the side for 7 years for incubation and teams that newly formed, especially when they're making their first titles, because that's when they're most volatile for, so they wouldn't be making the same mistakes that I did or do, hopefully not. These are some of the games I made or been part of. They are from different genres, from hyper casuals to hardcore Steam games and things between. So, most of the talk will be experiences of games developing this game called Rotgut, which is obviously a 2D platformer and with pixel art aesthetics. I'll be giving away 3 Steam copies of the game. So how it works is that I'm going to be asking questions, 3 questions during the workshop, and if you answer, I'll later on email you a Steam key for the game. So just in case you are not familiar with pixel art, I've prepared the trailer here. so everyone would be on the same page, what we will be talking about, and why we need a special session here for making pixel art with Unity. Why is it's not showing? It's not moving. Oh, it's not showing the video. It's like headshot. Yes. Who here knows what pixel art is? I think it's better we watch the video. All right, so pixel art, people are usually in two different, very opposite directions about pixel art. They either love it or hate it. So one of them are very wrong, obviously, but we don't want to talk about them here. But there's still time, I hope. So to make this talk more diverse and acceptable to people, I'll be covering Unity's 2D toolset and add special information and tips and tricks you need to know if you want to make pixel art games. To make it more diversible to the other group of people who are, I hope they are trying very hard to love pixel art. So this talk will be allowed lots speed painting, if you may. So before Unity 4.6, we had to do a lot of strange things to circumvent to have proper 2D tools. But right now we have a very good foundation and support for 2D in Unity, and we'll talk about them here. So the basic building blocks of such games are sprites and tiles. So we'll be covering how you can make them in Unity and why they are good and essential for making such games. So first one is Sprite Workflows. Sprite Workflows are a way to make sprites in Unity. You see, characters animation consists of a lot of different frames hand-drawn by artists. So you would say, without doing the crazy things we can see here, I can import them all into my project, put it on Animator, and it would animate, right? Wrong, because each of them would take a lot of memory, and we don't have a lot of memory still right now in 2019. You may say my computer has like 8 gigs of RAM, but first of all, if you want to target mobile, the less RAM you have is better, and RAM is always essential, so you never have enough RAM. The way Sprite Sheets works is that you put all your frames of animation in one single file and give it to Unity, and tell Unity how to slice it up and dissect it, so it would know when you say start running, from the big picture, would select this cell, display it on your game object. From here, playback, like 10x frames of animation, right? So if you want to jump, would go to frame 20 and play from 20 to 25. If it's falling, from same image, go to frame 30 and play to 35. So we are not changing files. We are saving draw calls. How many of you know what draw calls are in Unity? Okay. Draw calls are when we have to change, when a scene is rendering, a frame is rendering, Unity has to change materials and objects that are in memory from graphics card to make it work. The less we have to change, it's better. Some older games have their all art files in a single file, like in NES, Nintendo Entertainment System, 8-bit era. If you find their files on websites like sprite-resources.com, you can see how they work. They're all in a single file. So that method is so good that from 80s to right now, it's still viable and working. So in order to have, this method is not exclusive for pixel art. If you want to make 2D game, if you have hand-drawn and pre-made art, you should use this one. Or it's very likely that you will run out of memory. The other special kind of treatment we got right now from Unity for 2D is 2D physics system. Before that, we had to constrain 3D system we had, physics. But right now, we have implementation of Box 2D inside Unity, and it works very good. And you can use it in almost exactly like how Box 2D works. So you have joints, if you want to make like a chandelier or bones or ropes. You can even change them in runtime if you want to, for example, cut a physical object up. Like in one of my games, map is dynamic, and when people are shooting through some special kind of walls, wall will start to deteriorate, and bullets will go through. So it's a physical object, but it's changeable during runtime. Good thing about Unity, and they are still doing it right now with technologies in preview like dots, is that they are using the same UI for new technologies. For example, right now we are seeing how 2D animation works, but it's the same menu, same workflow that we are used to from 3D game objects, but now it works in 2D too. So that's very good. Also about particles and effects, right now you can make 2D particles in Unity. That's very good, that's very performance. 2D lights recently introduced, so you can have proper 2D lights, and shadows are coming very soon. So you could cast shadow through a wall like with a flashlight, pointing through an object. You could have normal maps on objects, on lights, to make them feel 3D, but without making them a 3D mesh or 3D object. So if you want to import your art to Unity, first thing you have to keep in mind is pixel perfectness. So what is pixel perfect? Because Unity is a 3D engine at heart, it treats image files as textures by default. So you have to tell it to make it work, to don't apply any kind of normal in 3D games filtering to them. Because in 3D games, we don't usually like to see pixels. And the artists, programmers, everyone's doing their best to make it look less crisp, make it more smooth. If you go very, very near to an enemy, you can see pixels of its textures. You see very smooth implementation of those pixels, right? But we want to stop Unity from doing that because our art is made in pixels and we want to see them very big and chunky. So with these settings, you can stop that. The most important one is this filter mode, which says points, also known as no filters. So Unity wouldn't change anything on the file and would deliver it to you. Because when Unity reads file from your memory or hard disk or wherever the file stores, maybe cloud, it goes through something called content pipeline. It would change it, like optimize it for memory, optimize it for rendering. But with these settings in Inspector, we are trying to stop those. So I don't think you can see from over there how they're different, but later on, when you see the slides, you can see how these images are different. Okay. How many of you know what package managers are in Unity? Okay, very good. I know too. So there is a package for Pixel Perfect in Unity called 2D Pixel Perfect. Yeah, you can install, and it helps you and configure your camera. Because it doesn't matter how good you make your pixels work in Unity, if the camera is meant for 3D objects, it will ruin your image again. So first you had to fix content pipeline to doesn't ruin your pixel art. Then you have to tell your camera to do not blend any pixels. Make them look crisp as possible. Okay? The way it works that before this package, we had to render our scene to a separate texture called render to texture. Very good naming. Thanks, Unity. And then feed that image to the camera. So your camera wouldn't render the scene. It would be rendering an image that you made yourself from the scene yourself to make sure it is rendering the way you want it to. Okay? But right now, we can use Pixel Perfect Camera. And after importing, can I see my mouse here? Yes. After importing that package, you add this component to your camera called Pixel Perfect Camera. And we have some settings here that are very important. First one is pixel per unit. What does it mean is that how many pixels in your art represents a unit in your world. All right? Because if you think about it, we are importing images into a 3D world, and our 3D engine cannot understand what is it. So it has to know how big is that file. Is your character this big in this world? Is it this big? So the higher pixel per unit is, your object will be smaller. Because it says the 100 pixels in that file is just 1 unit. If I say 10 pixels is 1 unit, my character will be much bigger. All right? It's like how you change rupees to dollars. The more rupees you pay for a dollar, the lower the value of your money is, right? It's also known as PPU. If you read it in Unity's blog or other places, it's called PPU. Okay. The second one is very important as well. It says reference resolution. What is it? It's that when your artist was drawing your art, what resolution he or she had in mind when they were drawing the image. So it would also help the camera to know that the maximum resolution of the rendered image will be this size. So it wouldn't draw whatever it wants. If you've played games like Shovel Knight or games that try to really hard to represent 8 or 16 bits, on 16 to 9 screens, they have pillar boxes around. They have black boxes around because their resolution is 320 to 280. Right? It's like when you put Unity's camera to freeform. You see how hard you resize the window, it will produce the image. But user's monitor has certain kind of aspect ratio, so you have to keep in mind for that. Another problem you will face is crispness of pixels. And it shows the problem shows itself when you are rotating your object. How many of you studied computer graphics, a course, something? Okay. So if I have a line, my monitor is basically a matrix of blocks, right? They have colors. But a line in math is an abstract form. If I have a line, I have to put it into some kind of blocks so it would break, right? Pixel art, everything is perfect when it's like this. But when we want to rotate it, because we have very low amount of pixels, it will deform by default. Because no one knows what to do with your image. If it's a high resolution image like this was a low resolution image, by the way, this was a high resolution image. Because it has so many pixels and resolution is so much high, no one would really notice it unless they are like moving their eyes here and try to criticize your game. Okay? But in low resolution games, like this poor guy here, you have to make sure to first not ruin your slides, then the lines you have should be jagged like this. Because we don't have this many pixels in an older form or older console that we are trying to replicate here in modern technology, right? So your lines should be jagged and broken like this. On the right side, I think there is a highlighter here. Pointer? Yes. What we want is this, not this. It's actually arguable. Some people like it like this. Art is subjective, but I'm always right. So, if we don't upscale our render texture, we get this. But with upscale render texture, we get this. So we don't have much time. Let me go a bit faster. If you have any questions, I'm sure I'm explaining so good that you wouldn't have any questions. I'm sure of it. But if there is such questions, I'll be waiting outside. So because we have so many slides to cover, and I'll be sharing my email too, that I will reply very soon. I assure you. So another problem is pixel snapping. Pixel snapping, you can see it from there. But in pixels like this, when it wants to, and it has to decide between 4 pixels and has 1 pixel to show, it tells Unity which pixel by which rule to choose. Okay? So, an example that if we don't use proper filtering or remove filtering, our picture will be like this. Do you see the details that we are losing in the image? like here, like here, like here. So another aspect is max size. Max size defines that whatever image you feed into Unity, the size it will actually get when it's running the game or imported and using it in the game. So if you, it's a very helpful option, because if you have an 8K file and Unity is multi-platform and you are targeting, for example, Android, you know your device doesn't handle its memory, doesn't handle files for example, like more than 4K. So this scales down the file, but we don't want scaling. With max size, images like this. In max, because we want to have complete control over our file, we tell Unity to don't change anything, and if it breaks, it's our fault. So, how these tile sheets work in Unity? We talked about how each and every cell of them is a single represented file, right? So obviously we can use this. This is a file like 1024 by 1024. This is not a single reusable object. This is a collection of smaller files like icons. So how we should do this? The thing is, we try to slice the file with Unity. In Inspector, we have the option to tell Unity if this file is a single file or is a collection of files, multiple files. If it's a multiple of files, then we have to tell it how to dissect it. I don't want to go into details because you can find it very easily online, but the result is these green boxes here. Each of them, as you can see in the inspector here, our file, this one, is now considered and understood by Unity as a collection of smaller files. And you can treat them like normal images that you would import, with the advantage of saving a lot of memory. So we have tiles right now. How to make a level like old school Mario games? With built-in brushes, we can easily paint them into the world. See? I know I should be doing this in Unity, but because of technical difficulties, I could not bring my laptop. So I recorded some videos. I'm sorry for that. And memory-wise, this doesn't take so much memory because for each and every cell, Unity knows how to read that single image from that file. It's already loaded. So it's very efficient. It's not that you would go run home and make Skyrim with tile system efficient, but it's very much more efficient than having single files. Another good thing is that we can have tile map layers. So if I want to decorate this file, I could make a layer with this tile set and another with this one. And good thing is they can have different sizes. So if your art is like 12 by 12 pixels, each cell, your decoration layer can be bigger. So you are not forced to dissect a small palm tree into like 12 small tiles and try to paint with them. We can have bigger tiles, we can have smaller tiles. That's very handy actually. Okay, so now we have the representation, we have the art. But how make my character stand on it and not fall down? Any idea? Collider. How should I put a collider on it? You answered my question.
I did, because I'm from 3D background.
Right. So anyone else? I'm sorry? No, it's a platform. It's from the side. We are watching it from the side. Imagine, yes. We can have a box collider, but we don't have a box right now because form can be different. A box collider would be, yes. Mesh would be better, but problem is tiles are usually very big. Imagine Mario's levels and have a big chunk of mesh like that. It's not that efficient. You're getting there. There is something else before that. I'm sorry? Polygon, no. Composite, yes. But, let's see. Yes. Who said that? Okay. You're right. There's a component called tile map collider, and if we add it to our tile maps, it would generate very nice lines of physics around our object. Like this. But we have another problem. I'll get back to that slide in a second. Problem is, each one of my tiles will have a box around it, and it's not efficient. Because if my level is like this, and it's consisted of smaller tiles like this, my character never collides with the inner ones in a normal game, right? But we have colliders, like having a stack of boxes, but you can walk only on top of them. But Unity is always calculating the intersections between all of them. But we don't want the middle ones, right? So we have another component called composite collider that we add to our tile map, and it tells Unity to combine all of them and just have the ones, the border ones, right? And the great thing is it can be modified during runtime. So if you want to make a game that your levels are destructible or something, you can easily do that. Even better, this helps you make a level editor for a game, because users can draw their levels and start playing. Or even better, during playing, make their levels. Okay? Because it's very lightweight. I think we're running out of time. How much time do we have? 15 minutes? Oh, thank you. I can see that. Another good thing I like about Unity is that they take they are using to make Unity itself to us. So there are no different classes that they use to make like animator system than the APIs that we can call. That's very good, and it helps here. So after you mess around with tiles for a bit, you want to have more advanced kind of tiles. And there's a very good GitHub repository called 2D Extra that you can import to your project to have objects, to have tiles that are scriptable objects. So you basically could have rules over how your brushes or your tiles work. So what we've seen so far is the basic tile Unity provides, but it's very easily extensible to your games and to your needs. So let's see a couple examples here. First one is called rule tile. If you are making big levels with different kind of tiles, it really gets so hard and frustrating to make sure you are putting the correct tile on the correct place. For example, if you want to make a boulder like this or a platform like this, you should be very careful when and where you put each of these tiles, because they are not symmetrical. They're designed for very specific places. All right. So what we can do is to make a rule tile and assign rules and provide arts and tiles for different situations. What this gives us is that you can easily paint that I need a platform here, and the art and how it should be configured is done automatically. The great thing is it can be updated on runtime as well. So if your game is destructible or is changed or procedural is made in runtime, like in roguelikes, if you may, they can benefit from this very good. So you would make your level in your code and just give it to your tilemap system, and it will be rendered beautifully, at least in theory. Nothing ever works that good, ever. Another good feature is animated tiles. Animated tiles tells Unity how to animate each tile. So, for example, if I want to have a waterfall, it would read different tiles with different speeds and different sizes. And these can be combined. I can combine a rule tile with an animated tile. That's very powerful. Also, you have another option in your tile map to say how fast you want your tiles to appear. So you have either here or over there. Another very useful extension to tilemap system is brush tile or prefab tile. Prefab tiles are like, if you've seen editor from games like Far Cry or Skyrim or almost any open world game that they need to make a very, very big chunk of level very fast, they have brushes that would that would place prefabs or instances of objects or game objects onto the scene. So they wouldn't open their project file and drag a tree over there. Like they see the world as a zoom out bird's eye view. They say we want to have some trees here, some roads here, some houses here. They don't have time, games like Assassin's Creed, to sit down and place each of them, especially if you're prototyping and you need speed. You want something that's good enough, that's just like not robotically placed cubes just next to each other. So imagine if you wanted to have some boxes here that are randomly rotated to represent house, we could do that with prefab system, with prefab tiles, I'm sorry. So if you see in this video, if you can, and good luck if you can, you have very good eyes. I thought we would have a presentation here, but you could see that this object, which consists of 6 different tiles, and because it's a game object, has its own logic, we can easily place it on the world. I wouldn't need to be worried about how to put 6 tiles and group them and attach a game object, layer it, put a tag or something. I have a working game object, I have a brush. I tell it to put my game object onto the scene. There is a concept called micro games Unity recently introduced that has an FPS, a kart game, and a platformer right now. If you grab the platformer one, it's very nice. It has a very good tutorial on how to work, how it works, and how you can extend it. It's very moddable, modifiable, and you can upload your mods online. And actually, they'll be holding a game jam, I think, 2 weeks from now, that you can contribute to. If you've never been into a game jam and want to make games, I highly suggest you to attend to a game jam. It's very good introduction to the whole process in like 1 day or 2, something like that. So grab the project and try to mod with it. You can use all the tile systems and all the prefabs and things we talked here in the platform microgame, and it's completely free. It's on the asset store. It's made by Unity themselves. So that's it for me. If you have any questions, if you have time now, we have 8 minutes. You can ask right now, or if it's more, I can wait outside and then talk. Thank you so much for your patience. So, questions? I'll be posting the slides on my Twitter, I think 3 days from now when I get home. Okay, if you don't have any questions, I think I'm done. Okay, thank you. These are the files I've used for presentation. You can get them. Okay. Thank you so much.
Thank you very much, sir, for telling us the 2D game development process and how we can use its tool like Sprite Editor and everything else. I really enjoyed that session, especially, and we would like to present our love appreciation from Unity.
Thank you so much. Okay. Thank you so much. Thank you so much.